time for Wise Guys Wednesday.
This week we're learning all about the greenhouse effect. Paul Kwiat, U of I physics professor, is here now.
Nice to see you guys again.
Nice to see you again.
Really missed your bow ties.
Yeah, we missed you.
Oh, thank you. Well, I've missed you guys too. You're going to be stuck with me for the next 3 weeks.
Oh,
all
man.
right. Let's get to it.
Another
start this crazy journey.
Yeah, so today we're going to try and understand something seemingly unusual. Why your car gets hot in the summer. Why it can be hotter inside the car, much hotter than it is outside the car. And also how greenhouses work. And also why the planet is not a big ball of ice, which is something that we care about. We don't want it to be a big ball of ice, of course.
So a lot to cover.
It has been for the past couple of months, but you know.
Not just locally, but I mean on average the whole thing. Right, so we remember I had the spectrum chart here that just says that light, of course, comes in many colors and that the different colors have different energy.
We can pull that up.
Hopefully.
Possibly.
Yes. Okay.
Maybe.
There we go.
There we go.
And so we've got blue particles of light. Blue photons have more energy than green, have more energy than red, and those have more energy than infrared. So as we go to the redder spectrum, we have less and less energy. And the other thing that we talked about a long time ago is that if you have an object that's hot, when the electrons in that are vibrating, they'll emit thermal radiation, and that's our next thing, which is just electromagnetic radiation. And depending on how hot the thing is, if it's hotter, then the electrons are wiggling faster, and you emit, in this case, like visible radiation, that's like the sun. And if we go to something down like me at not 1,000 degrees, but at a couple hundred degrees Kelvin, then I emit something more in the like 10 microns or something. So in the infrared. So if we go back to us now. On our camera here, and so I have here my favorite thermal imaging camera, so you can see.
I love this thing.
You can see if we zoom in a little bit here. There I am. In fact, you're probably hotter than I.
Oh wait.
Yeah.
Oh, I am.
Yeah.
Wow, what's wrong with me?
You're hotter than I am. We all knew that. Okay. And Aaron is the hottest of all of us. Okay, so that's all good. So what happens in a greenhouse is that we've got, so if we zoom back out here, we've got here the sun. So this is just a nice bright light which is pointing out. So the sun, and it's shining into the container and it's heating up the container. And so here's what's inside the greenhouse. And some of that light is absorbed then and it heats the plants and it heats whatever's in the greenhouse. And then that inside is not heated to the temperature of the sun. It's a lot cooler, but it's still hot, so it's radiating, and it's radiating in the infrared, which is you could see before. My hand is radiating in the infrared, just like we had in my hand or your hand. The thing is that we also have the glass of the greenhouse, and the glass completely transmits the visible light, so you can still see my hand being illuminated through this, even though I'm blocking this, the hand is still illuminated, but it doesn't transmit the infrared. So if you just look on the camera here, there's my hot hand. And then if I block this, then you can't see anything.
It blocks.
Right? Wow. So the plastic, or in most greenhouses, the glass actually block the infrared, and then they re-radiate it back down into the room, and then that keeps the room hotter, keeps the greenhouse hotter. The same thing happens in a car in the summer where the sunlight, the visible sunlight goes through the window, it heats up the car, which radiates in the infrared, and then that's absorbed by the windows and then re-radiated back into the car. So it's an extra heating mechanism. And the same whole thing happens for the whole planet. So we have, this was the other graphic that I had.
The third one.
Yeah, on the third one.
Blue one, guys, I think.
Blue one with the planet. So we've got the visible light that comes through the atmosphere, peaked in the green, and then it heats up the planet, and then that planet re-radiates in the infrared. If we didn't have any atmosphere, actually the planet would only be 0 degrees Fahrenheit on average. So it would be a ball of ice, basically.
Wow.
But we have up in the atmosphere, we have other molecules, so-called greenhouse gases, like water, and I guess you can come back to us now. You've got water and also CO2, carbon dioxide. And those have vibrations that match this infrared radiation, and so they can absorb some of the infrared radiation and then transmit it back to the Earth, and that keeps the planet warmer. And if because of that, instead of being at 0 degrees Fahrenheit, we're an average of like 60 degrees Fahrenheit. So a lot of times people hear greenhouse effect and they think it's just absolutely terrible. If we didn't have it, the planet would be terrible because everything would be, so many things would be frozen. So we absolutely are critically relying on it. The problem is when we get too much of it, and we will come back to that next time.
Very good. Tease. Thank you. Thanks, Paul.
Thanks, Paul.
Thanks so much. I love this camera every time. All right, well, if you have questions for Paul or any of our other wise guys, let us know because they like your ideas and we want to know what you want to see, correct?
Absolutely.
Absolutely, yeah. Always looking for new things to talk about, of course.
And still to come in the morning show, we are meeting a woman from Central Illinois who's getting ready to run.
Mona Lonio is here all the way from Peoria. You're going to find out when she started training for marathons. That's coming up.